Okay, so now we know the basics of permutations. You have a factorial where you put them all out. You have the situations where you're not choosing them all. And then we also have the parts where there's overlap. So here there are 4 factorial, 24 methods. Now that we have overlap with the L's, we cut it to 12, 4 factorial divided by 2 factorial. And then with multiple overlap, we have 4 factorial divided by 3 factorial. We also looked at the situations where you can have multiple of the same thing and then break those down. So now in your homework, you need to work through and look at some of your own situations. So this is Emmeline's example from last year where she took her name and there was 8 factorial divided by 2 factorial methods. Use your calculator to go and break that down. Get together with a couple of people or just pick names of people that you know and go and do that portion too. Here though, we want to look more at the theory. Instead of just having a situation where you're dealing with a name, what happens if you have letters in general? What happens if they're all A's? And by pausing the video and looking at some of these explanations here, you'll see what some of those options are as we get into the theory. This, leaving the theory here, is now practically what you need to be able to do. To take any word, any kind of problem, and break it down into its permutations. So referee is one of the harder words to look at because it's one of the only words, I believe, in the English language that has 4 E's in it. So when you're dealing with referee, you're going to have to divide out by the 4 factorial. Throughout the booklet, you'll see a bunch of practice questions that are related to this and the other pieces. Now a bit of an exception to the rule, and the only way to approach these questions are common sense. So if you're given a situation where you have a certain number of digits to work with, whether it's all 10 from 0 to 9, or an isolated subset group like this, you cannot use factorials. Really the only way that you could use factorials is if you had the most simple question of here are the 5 numbers, how many ways could I arrange these numbers? But when it comes to dealing with different digit numbers, it gets way more complex. Repetition is allowed. This would never give you a 5 factorial because 5 factorial would be 5 times 4 times 3. But you can have a number that is 4 times 4 times 4. In this situation, the blanks represent the possibilities, not the actual number. So why is this a 2? Because there are only 2 options where I'm less than 400. And those are the 2 options I start with. So I start with the limit, and then it can be anything or anything. So as you work through these questions, do your absolute best to go and figure out what the options are, and then check back with the answers that'll be posted to EdSP. When it comes to different 5-digit numbers, the other focus to look at is whether there's repeats or not. And the best way to approach these questions is to go and compare 1A to 2A. 1A, no limits. All 5 digits available, 125. 2A, we've actually already learned because that's permutations. So now you have the situation where you can use any digit you want for the first, then after that you're down by 1, and then you're down by 1. As you work through some of these other questions, we just have some rapid fire questions that look at all possibilities here. Letter arrangements, 3-digit numbers, flag coloring. And then finally, we'll move into some true word problems. And the only challenge that you have here is to go and pick the key numbers out. And so for a situation like 5 people standing in line for a photo, that's just going to be 5 factorial. But when you get into other situations where, for example, someone is sitting around a circular table, it's actually quite a different pattern because there's no start or end to the table like there is with a straight line. The final pieces that we'll move through in the booklet are your tree diagrams. Your tree diagrams don't need to look this good, but they do need to have nice clean representation. A ruler does not need to get used for all parts, but clearly labeled and then showing the algebra piece to it too. The most challenging question that I wouldn't spend more than 5 minutes on, because there's so many options, is the rock, paper, scissors example. And that simple game of rock, paper, scissors actually makes it very complex because you can approach the tree diagram from a win-loss situation or each possibility of both people using rocks, one person using paper, one person using scissors. So do your best with the booklet, and answers will be posted to EDSP. The whole approach when it comes to permutations is to try things, to make mistakes, and then the last component being to use technology as much as possible. So the NPR button on your calculator, the factorial button on your calculator are going to be really key for doing these more complex questions.